So next up today, we're going to talk about code intelligence in large C or C++ repositories. We have two speakers, both working at Ericsson. Colin Grant, he received a PhD in Germanic linguistics from Indiana University recently. And since then, he's worked as a JavaScript developer at Ericsson on developer tools. Benjamin Davis, he writes about himself. I've been a long-time developer building IDEs based on the Eclipse platform, usually for C programmers in the embedded space. Over the years, I've had the opportunity to build and deploy multiple integrations with CT and build up new Eclipse or CP applications. I've recently transitioned my efforts to building an internal C, C++ IDE for developers at Ericsson based on the Thea project and the language server protocol. Thank you, Benjamin. And Colin, take it away.
Yeah, thank you very much. And thank you to everybody for attending this session on indexing challenges in large C repositories. So predominantly, I'm going to be talking a little bit today about our experience at Ericsson trying to roll out Thea to our individual developers. We have a lot of developers working on a very large repository. And I want to kind of share some of our experiences and where we've gotten with it as we've rolled this product out to users. And I'm a little bit aware that this is kind of more of a Thea adjacent topic. Rather than being directly talking about Thea's core, I want to talk about a lot of the things that it takes to kind of build this product from the get-go. So again, I'm Benjamin Davis at Ericsson, and I'm joined here with Colin, also from Ericsson. We're in Austin, Texas. So being kind of Thea adjacent, there may be some terms here that I'm talking about today that aren't super familiar to some of you guys, and that would be around this notion of C repositories and what it means to be editing and working with C code. And so I know some of these things have been brought up in previous sessions, but I want to kind of bring up a couple terms that I'm using today just to kind of clarify. So first of all, I'm going to talk about a term indexing, and this is kind of like my catch-all term for a lot of different things. But what I mean by indexing is both the process that an application would use to parse source code and end up understanding what that source code means. And from an end user's perspective, what indexing means, which is, you know, they're going into the editor and they're seeing things like the ability to hover over symbols. They can click definitions, do reference searches, symbol lookups, all the different advanced features that you expect to see in an editor. When I talk about indexing, I'm talking kind of about both of these things and what it means, you know, when you're at, working with C in either a large repository or a small repository, or frankly, really any language, is that you're trying to give these features to users. So that's what I mean by indexing. You'll also hear it called by a lot of other terms. I think Microsoft likes to use the term IntelliSense, or, you know, code intelligence is a term that we'll use sometimes. Another term and concept that I think is one of the cooler things to come out of modern day IDEs is the notion of language servers. Again, in previous sessions, I think we've heard a little bit about this, but the idea behind a language server is rather than programming all of the language specific pieces, everything that it means to understand C code or Java code or any other language, rather than creating that stuff in a tightly coupled way with our editor, Thea or VS Code or Eclipse, whatever it be, we can put that understanding of the language and these indexing features into a standalone application or something else that we can use and bring that into Thea and give Thea an awareness of how to work with those languages, or bring that into VS Code and get that awareness, or VI or any other application that supports the language server protocol. Our language server can come in and export that functionality in a really meaningful way. So again, kind of looking at these two terms, I'm going to move into something a little bit more specific to C and C++, and that's CLangD. And for me, CLangD is kind of the gold standard in what it means to be working with C and C++. It's a fantastic language server, really, for being able to expose a lot of this advanced functionality to users. When fully configured, CLangD provides all sorts of features. And just kind of quick, from their website, the way they describe CLangD is, you know, it understands your C++ code. It adds smart features to your editor, code completion, compile errors, and so on. There's actually a picture that they provide too, which is showing them pressing Control Space and getting code completion in here, and you can see that it's saying, well, if the user is at this point, these are the possible completion options for autocomplete. And this is a language-aware feature. So you can see in this particular instance that VIA or VS Code is asking, at this particular location, what are your completion options? And CLangD is the one to respond. So I'm going to kind of share some of our experiences with CLangD, and I don't want it to be seen in any way as me disparaging CLangD, just pointing out some of the complexities we're trying to use it. But really, CLangD is such a fantastic effort, and I'm really grateful for the work that people have put in on it. So I want to talk about what it means to use CLangD for perspective. So you understand, as we were rolling this out in a large repository, in a large organization like Ericsson, what that meant for us. And really, in order to use CLangD, you have to kind of provide information about what your build configuration is. And so I'll use these two terms somewhat synonymously, build configuration and compile commands JSON, because the compile commands JSON file is really the format that is used to describe to CLangD what your build configuration looks like. So again, another term for it, compilation database, but it's all the same concept as this compile commands JSON file. So when we're building and going into CLangD, we need to kind of describe to CLangD what our build configuration looks like. And that includes kind of some C-specific things like includes and defines these directives. And we have to pass that stuff in. Includes basically tell where C files are located or where their appropriate like headers and other things can be found on disk. And defines and directives actually are going to specify things like branch conditions that can be taken before the compiler. And that's one of those particular things. So we kind of need to understand that. And another thing that I'll kind of point out here is that when we're generating these compile commands files, we're doing it across a huge number of different build environments. And so when we're talking about Ericsson, we use Make and CMake and Bazel and a lot of other different tools to build our repository, including a lot of internal tools. And sometimes getting an understanding of what our build is kind of a complicated mess. So I want to talk about how we gather this stuff. So in a smaller C repository, some of these solutions might make sense. In a larger repository, some of them might make sense. You really have to kind of fit it to your organization. But if you're trying to figure out how to generate your compile commands file, the first thing you might do is Google, and you'll come up with some of these things. So for example, you can use a product called Bear, which will actually sniff your builds kind of like strace does and pull out the exec commands, and it will try to reconstruct the compile commands based on how the compiler is getting called. Some of the build tools, like the LLVM compiler itself, will actually has a -mj flag, which will generate it. CMake has this command that you can stick in front of it that will cause it to build. Bazel, there's projects out there, and we actually try to do this ourselves, is to query Bazel to try to understand the dependencies and build one. And some users might just take to building it manually, saying they know what the compiler flags are and understanding what the build configuration is and passing that through straight to CLangD. So all this is supposed to generate a standard compile commands JSON file. And then you're just supposed to launch up CLangD, point it at this configuration, and receive those advanced code features. But in a large organization like Ericsson, this gets complicated pretty quickly. So in the simple case, just kind of showing one of these, in practice is really like, I've put a demonstration here of just how using, I'm just compiling a C file with a flag like that says what my include directory is. I get an output, which looks like here's your JSON file. And then you can see that here, which is basically for each C file, how it's built. This is kind of the structure of a compile commands file. So I want to talk briefly about what makes C an interesting and challenging problem. And that is that I like to blame the preprocessor directives mostly. And these are things like a block of code that says if def and end if, which is basically a branch condition that's taken before we even compile. And you'll see why I think this is such a challenging problem a little bit later in this presentation as I talk about some of the scoping issues that this creates. But basically, we end up at a point where we have a lot of different build configurations inside of Ericsson or inside really any C project, especially when you get to a large enough size, where the number of these directives really shift the number of ways that you're compiling this project in a large number. And so that creates a lot of additional problems. These preprocessor directives can really be passed in at build time. And so you're really kind of branching the code based on your build configuration. Next is the same problem. I think a lot of languages find, which is really discovering dependencies. And then again, talking about just the sheer number of build configurations that you can have in this case. And I want to kind of point to specifically some of the problems we might face in trying to decide what does it mean to be in a build configuration in a large repository like we have at Ericsson. And so kind of looking at this, you'd see, well, I have this large repository here, which is what I'm looking at. And there's so many different potential build target products, right? So I'm going to go take out of my repository slices of it to build what it means to be in a product. And I might have, tens of, or maybe hundreds of ways of building my product or different products from my repository. And then on top of that, you'll have a lot of slices of people like I'm working in this particular subgroup or project, and that's the way that they build their code is on that particular project. And then they might build their code with respect to their test cases, which obviously those test cases aren't necessarily getting compiled into the target output. And so which build configuration are you using becomes really kind of a complex problem. And so again, pointing out that like in this particular instance, we might be building like a small piece of, firmware here or a different set of tests in this case where test code may or may not be included, but the user's still going to be able to expect some sense of CLangD and these things working. So they need to be able to go into those build configurations. And so we potentially have multiple slices and other problems that come in. And in some cases, we even build the same C file in multiple ways, right? And that's really what we're talking about with, again, these preprocessor directives and some of the complexities of C is that, when you're presenting it in the editor, now you've got a case where I've actually built this thing multiple ways. I'll show some more specifics about this in a moment. So we started looking at how do we roll this out to our users? How do we build an IDE based on Thea, give them, CLangD when they start up? And we said, well, building one of these targets takes a really long time. And maybe what we can do is just build the targets for the user, right? So we're going to go pre-compute and pre-compile these compile commands JSON file. And so early on, we set up build in our nightly builds or said, we're just going to go build all these things, stick them up somewhere where they can be downloaded as part of the application. And we pretty quickly hit a lot of problems with this. The first problem we hit is just the sheer amount of time it takes to do builds on a large C repository grows very quickly. And so we were saying, okay, we're maybe 2-3 days in trying to build all these different configurations. And then by the time we built them, the source code was already out of date. I mean, you're talking about hundreds of commits in a day that just push it directly off. And then we could try to make that faster, but then we started encountering other problems, right? Where users were like, they were building a small project or they're building something that they want their test code in. And now we can't include that and bring that in because they're, downloading in these, pre-built build configurations and we're not accounting for their particular problems. Next, we had this problem where we're saying, well, if they've also diverged enough, they have their local branches, they've made enough changes, those things don't potentially get picked up well either. And so in the end of this, we're kind of like looking at this and we're like, well, this is kind of an overall problem, putting all this together, and we're not really able to build these pre-compiled compile commands. And the last point here that I also wanted to point out was we also have a lot of source generation that happens in our process where, we're building on a UML-like, UML similar language that generates in the C code. And if you have these source generation things in your process, I think it also dramatically increases the complexity of understanding how to build and create your build configurations. So we had all these problems where we're like, well, we don't really know how to pre-compile. And then we started looking at other problems that we were having as we were rolling out Thea. And so kind of go in this a little bit. I've defined this particular problem set as like a global index problem versus like a compiler scope problem. And you have to excuse these two crude terms that I'm doing. They're mostly for discussion purposes. But the basic idea was here is what happens with a build configuration in a C file is that really there's multiple ways now of looking at that C file. And if you're looking at it from the perspective of that build configuration, you're not looking at it as a person, as a programmer is where we're looking at a C file and we're saying, okay, well, if this block happens, I'm in this block of code, but else I'm in that block. We read both those conditions, and both those possibilities exist to us as we're programming. But what happens if you're looking at it in the global scope, you're like, well, I'm seeing everything. And so that's where I kind of define this global scope. It's like the way that we read the code. We're looking at it and we're saying both of these if and else conditions can be true. And so I look at it as kind of like the multiverse of the project. All the different ways of browsing that code and looking at it could be true. And then I'm thinking about it from the compiler scope perspective. And really it's where you're thinking about things from a build perspective. So where the branching occurs in the code, you'd kind of be looking at it and being like, well, I'm up here or down there, and everything else is basically non-existent to the indexer. So I set up kind of like a quick demonstration to kind of test the limits of this and play around on it, but also to kind of describe this problem. And we look at it. So I've created a really simple C example with just a couple files here to kind of show it. But basically I define a C file, a small C file, and 2 header files. And the 2 header files are in different directories. And the point here is to be able to include them. And you can kind of quickly see what I'm getting at here. So I go ahead and create this main C file, and it has foo.h, and I'm going to pull that in from somewhere. And you can see that I created 2 of them. So I created foo.h here with a slightly different format, and another one inside of include2 with a slightly different format. And having these 2 different formats, I'm then going to try and see the way that they present inside of Thea using CLangD. Go ahead and compile them. We already saw this, and this is how I'm going to build. And you can see that I pass on an include directive, which says go and use include1, get our compile commands. And then when I'm inside of Thea using CLangD, you can see pretty much the way we expect it, that the compile commands was saying go use include1. So now when I'm hovering over this symbol, I see one definition of it. Now, this is an interesting perspective, but the reality is that if I was looking at this thinking about this from the editor perspective, I kind of want to see both of them. Because what happens if I go rename this symbol and I don't really I go rename this symbol, but I only renamed one thing and I had both of them building, I would get a compiler in the other build. So interestingly enough, you can kind of fake Thea out or CLangD out by opening up both header files and kind of simulate what it means to be in the global scope, which is if you right click on the symbol and you can see that both of them come up, right? These are both valid ways of compiling the program. They both compile, but they're 2 different build configurations. And so you start getting to this point where you're like, well, what's the best solution here? Because if I'm a programmer and I want to do that rename, I really need to see both instances. And we started asking some of the other developers what they had been doing, and some of the C developers. And they say, well, I use tools like Cscope or some of these other tools. And they go in there and they find both these references in there, and then they'll know where to go and edit. And of course, you can integrate this in the VI and whatnot. And they get this tool. And they're like, well, this is working pretty well for me. So we said, well, maybe we can replicate this functionality. We tried various different tricks, but we couldn't really fool CLangD. At the time I was testing it, this is what I was trying, and it wasn't working. It was, if I passed 2 include flags, it was just taking 1. And so we're saying, well, I mean, we have a little bit of global scope issues. And then that kind of led us to the next step of testing, which is, well, what happens, in areas where your build configuration is not active? And this is what I'm talking about, where really there's a blindness that occurs relative to your build configuration. When you're talking about large repositories, this thing gets really out of hand really fast, where huge blocks of your code are just inactive. So if I come in here and I'm like starting to type things that are obviously not valid C code, now I get to this point where I'm just generating nothing in here. This area is kind of inactive. And there have been some nice patches to CLangD to kind of make this gray, or kind of to show what's inactive. But if I want to edit this file and have all those code features enabled on my index working, I have to constantly be switching between my build configurations. So we find instances, and this is an instance down here where the auto completion wasn't actually even working because I didn't define this macro in my build configuration. So as we're working on this product to deploy this IDE to our users, we kind of encounter this problem with the first impression problem. We know basically that we don't really have a good way at Ericsson to pre-compute these indexes. The remote indexing stuff wasn't really working that well for us. And we also have these global scoping problems. And we're thinking about what it means to be a developer coming into the product for the first time, opening up your source code and seeing this environment. And we're like, well, we're not crazy about what we're getting, because we pop up CLangD with no configuration and there are thousands of errors. Searches aren't really working for us, and users haven't done a build yet, and we can try to push them to that point, but we're worried that users are like going to drop off the IDE before they properly configure CLangD. And frankly, at this point, we get a lot of feedback, which is, why don't we just pre-compute everything? But that's a very challenging problem to solve. Next is the problem where a developer is working on project A, but they need to go navigate in some other similar project like project B, and there's nothing there for them. They've configured CLangD for project A, but now they go look at project B and that one's not there. Or their build configuration wasn't properly set up, and maybe they're only spending a few minutes in the other project. So what do we do if they're just using a small piece of the world for a few moments? Do we expect them to go know how to build that other piece of the world and use that? And so this creates an additional challenge for us. And again, we were just having problems with errors popping up everywhere with unresolved symbols and things like that. And that's never a good environment for a programmer to be working in. So we started thinking back to some of the things that we had encountered here and trying to figure out, well, what's the best resolution? And it kind of occurred to us, well, people were kind of like using Cscope. And so we thought, well, let's bring Cscope into Thea. And, there are various ways to do this, but we started thinking about, well, yes, we could add commands to Thea so that you could go and use Cscope, but maybe it's better to integrate it in the way that CLangD does. And so we say, well, let's go ahead and make a language server that uses Cscope. And there's a project out there, the LSP4J project, which is an Eclipse project that provides the language server protocol for Java. And this is a fantastic way to just go build yourself a language server to be able to do all the functionality that CLangD could do or other things can do. That stuff's all exposed to you. And you just really have to fill out the core logic. And it's a great project. So we start building this project so that we can start with reference searches, for example, and kind of work our way in. And again, this is a picture of CLangD running, or excuse me, of Cscope running on the command line. And you can see we're going to go in here and search on a particular symbol and get those results. And so now we just want to integrate this with a language server, and we're just going to wrap it up. And so we start down this path, and it doesn't take long for us to hit a big wall and realize, well, I can't do this because it's going to create too many complexities trying to do this in a, understanding what you're even looking at. And part of that is you have to understand, again, back to what a language server is. The language server is given, basically a file and a cursor position and says the user wants references here. And you really have to take that and parse it and understand what the user is looking at, and then you can return the results. So we realized we're going to need a C parser because we don't know if the user is looking at a comment block or if they're looking at something meaningful. And so by bringing in a C parser, we'll be able to answer those questions. The other reason we realized we needed a C parser is a lot of times the returns that we're doing, and you can see that Cscope is short-circuiting this a little bit, but the returns that we're trying to do is, say you're hovering over a function, ideally we return you the entire function definition or some meaningful format of it, rather than just returning you the first line. Because if we return you the first line and your parameters are continuing down in here, as over your 80 characters and people are breaking them up, now you're not getting the best output to the user, and you've created, maybe not the best output that you could. So we realized, anyway, we were going to need a C parser. So being in the Java land, we decided, well, there's CDT, and CDT has a parser. So we would go grab that. And so we're kind of heading our way down into the Eclipse world a little bit more, where now we're working with LSP4J, CDT, and we're developing a product that can go parse C files and ask where the references are. And so we kind of started looking at this and adding more things, and eventually ctags worked our way into its product. And the final goal was to kind of have something that looks a little bit like this, right? We get a language server request that comes in that says the user's looking at file, line, column. They want definitions or references or a hover, right? And they want to hover over this symbol. What is it? And so now we can use CDT to read that C file, generate a syntax tree. And then from that syntax tree, we can look more deeply in and see if we can answer that question or whether we need to go a little bit further. We need to go to an index. So if we don't, we can just respond to the user and say, oh, you're looking at a variable. It's defined within the scope of this function. Here's the answer. And we can return that. In here, assuming that we have to actually go look, we can use ctags or cscope to resolve that reference in kind of like almost like a string match kind of approach. And there's a little bit more sophistication that goes in there, but that's the concept is to go look up where that symbol is, use CDT when it gives us our answers of where those things are to go parse, the results, go look at file 2, see if that stuff makes sense, and then format it. So now we can return to the user a response that looks something like, you were asking for a hover here. We know that's in these 2 files, and here's a response. Here's 2 function blocks, and return that to the user. So we've looked at introducing a little bit more of the different kinds of middlemen and different ways of doing this. And honestly, you can replace ctags with pretty much anything. You're just trying to do some kind of a symbol lookup. And I think, interestingly enough, that maybe at one point CDT might have even used ctags or something like that to provide its indexing format. So to talk about functionality for a minute, really we're trying to get to this point where we're giving a good user experience. And doing this, we've been able to provide fully functional, completely unconfigured experience to users to give them completion, definition, reference searches, hover, outline search, a lot of these different pieces of functionality that you would expect from a language server. And frankly, there's no reason why we couldn't take it further and offer diagnostics and hierarchy, etc. That doesn't mean that this is a replacement for CLangD, but it's a good first step. We're trying to get over that first impression problem. One of the downsides to this, of course, is we're probably a little too broad. Sometimes you really do want to see things at the level that CLangD gives you that information at. But for a large repository, it's hard to just cut out huge chunks of it and pretend that your indexing is only occurring at this small point. And of course, more features could potentially be added to this. So this is a product that we're potentially looking to upstream, make open source if there's interest out there. So if you find yourself working on an open source, working on a large C repository, and this is something that you're interested in trying out, this is something that we're kind of looking to bring back into the FOSS community. So I want to talk about, quickly how this is solving our first impression problems, because we pulled this out there and now users can come in and launch the IDE. And then we want to give users the choice to switch from this form into a more sophisticated indexing form like CLangD. But we understand that there were a lot of complexities. So now we can help the user just by going and building. Now the user can switch over to CLangD, and we don't have to demand that they do that for projects that they're unaware of. Now they can switch over at their leisure. We realize this causes a downside a little bit, that users have to figure out, what kind of indexing mode they're in, and maybe it's not entirely a consistent experience across there. So there's definitely room for improvement. But we think that this is a great starting point to give lower resistance to users being able to start up. So I want to talk about briefly some of the other things that are out there. So for example, I know that Microsoft has their C++ tools, but my understanding is that that's only available for VS Code. And so even though it's a plugin that might potentially work, I think it's not available as FOSS. There are, of course, some other language servers which I haven't talked about today, CCLS and CQuery. And I know that there's a VS Code plugin that, for instance, would use GNU Global, but it doesn't use the AST. And I think previously, as I was talking about that, why we wanted to be able to use that, and some of those things, like if you're hovering over a comment block, you don't want it to try to look up the word the as a function or something. So we're trying to, get really the best result out of this. So that being said, is kind of our approach a little bit to try this. I think Colin's actually just going to show real quick a little bit of a demo of this product in working, so you can kind of see a little bit of how it resolves a project.
Sure. Okay. So Ben, if you would stop sharing, I think I can start.
Okay.
Let's see. Here we go. All right. So what I'm going to show here is a little demo. Here we've got Thea. And this is the FFmpeg C code. I pulled this down this morning. This isn't the first time I'm looking at it, because you should never look at it for the first time in a demo. But I haven't done any configuration. Yeah, so I just want to sort of show how things look when you use our language server. So I bring up a C file, and you can see here we have this indexing thing, and it says it's going through about 4,000 files, and now it's done. So of course, you know, as you have more files, that'll take a little longer, but it's very quick. And then I can come over here and hover, and it turns out that this function is defined elsewhere. We've found one version of it, and we get the whole text of it. We can click the link here or do sort of normal control clicking, and we appear over here if we want to look at the context a little. You know, so we can hover and get types as usual. Yeah, again, very quickly. And if we want to look at a little bit more complex hover, we've got some pointer dereferences over here. And this is one example of where indeterminacy comes in. So it turns out that this struct may have more than one definition, many in fact. And since we're in what Ben referred to as this global scope, we're not actually sure exactly which definition the user is going to get when they compile. It may be determinable. It may be that there's only one of these potential sources that this file will ever refer to, but we're not sure about it. So we just tell the user, here's where it could be coming from, and they can investigate those possibilities, or if they're smarter than we are, they can just go to the one that they happen to know it's from. But we can also get, let's see, where was a good example? These are all, we should be able to get some good fully formatted struct definitions. That was this one. So here, when we hover over a struct whose definition we can find fairly certainly, this only has one potential source, we're able to show the user the whole thing. They can look at what other fields are there and get that information immediately. Again, of course, they can click in, and we can also do auto-completion on this. So we have all of these fields that this struct might have, and all of their types as well. And all of that with no knowledge of the code on my part and no configuration of the server to understand this code in particular. And as Ben said, we're still working to add a number of more sophisticated features. We have some outline capability, but not much. We're working on adding call hierarchy at the moment and other sorts of things that you expect to get from a language server.
Mm-hmm.
All right, thank you.
I see one question here. It's asking, Marco's asking if we are using, which Thea install we're using, and
so
which, yeah.
This is latest master. And this is the Electron example application. Of course, usually we use this in our product, but I just wanted to show the sort of how this is integratable in base Thea and how we haven't done anything special to make it work for us locally.
Let's see. I think I see a question from Matthew, which is, I don't know, is pragma once or if the up a race condition?
I think this is a survey for the C lovers in the room more than a question.
I mean, you know, it's funny, but we find ourselves, you know, like I find myself more of a Java / whatever programmer, and well, I spend time in C. It's really not my primary language. So it's interesting to me a lot of times to be coming back to our developers and trying to offer them a great C development environment when you're more of a Java programmer myself. But this is it's a great example, I think, of being able to integrate something into Thea that we're trying to put the user focus where it belongs.
I think Matthew posed a more serious question about whether, if this is upstreamed, there are areas where we could use some help. Definitely.
Yeah. I mean, in a lot of ways, this started out as an interesting little, side project of, can we wrap Cscope, and I hope that kind of, as we were telling the story of how we got here, it was kind of like, we noticed these glaring holes a little bit, but also like, well, can we build something like this even? But there's definitely a lot of areas of the language server protocol that aren't fully fledged. We were talking about diagnostics and stuff that, that's in there. Interestingly enough, too, I mean, the fact that we use CDT, for the parser also means that potentially we could use some of the other pieces of it. And I would say, for example, one of the things that's pretty poor too is C++ support. Primarily our language that we use internally is a very C-like language. So it's almost so close to C that it's basically C, but there are a few deviations, but not a lot of C++.
And one thing you mentioned is when we do our ctags search, it's a little fancier than string search, but not a lot. And ctags does provide enough information that we could be a little more sophisticated there and give the user a little bit, you saw there could be like 7 or 8 potential sources of a symbol. And we could likely cut those down with a little bit more intelligent handling of what we get from ctags, for example. And maybe some more intelligent use of the context, like if we can see that the user or the local code expects something of that struct, then we can check the struct definitions and eliminate any that wouldn't satisfy that expectation, because maybe they're in some completely unrelated compilation scope. And we're not doing that sort of thing at the moment.
And certainly there's room for improvement in determining when our index is out of date and things like that. There's honestly a wide wish list that we have on this product. The next question was asking if we'd be part of CDT Cloud. Right now we're not upstreamed, so I don't think they would have access to it yet, but I also don't know what their plan is for that. It's certainly something that, if we upstream this, I think, might make sense for them.
And as to your question, Matthew, about whether there's ordering of the options when there are multiple sources, they are grouped. So if we find that a definition of a symbol has identical text to a definition elsewhere, then those will be listed together. But there's no explicit sorting of the potential sources at the moment.
Mm-hmm.
It may well be alphabetical originally. It's basically in the order that ctags gives them to us, so it might just be in ctags discovery order. I'm not exactly sure.
Yeah, I mean, there's certainly room for improvement there. I know that we've talked about taking a more sophisticated approach to the way that we return completion options, for example. So this is kind of a fun little playground to play into. But I think ultimately, like, one of the main points that I was trying to get across here is that, there's a lot of emphasis placed on the I'm fully configured state and what it looks like to use a product once you're fully configured. And I think it's also important to focus on the state of the user who's first coming into the IDE and is using that source code, browsing around and isn't configured. And so that's kind of what I hope to address here.
As I said, I hadn't built and don't know how to build the FFmpeg code, but I was still able to get pretty good navigation results in a lot of cases.
Are there any other questions?
So it looks like that may be it. So thank you very much, Benjamin and Colin, for that super interesting talk. And thank you for all the work that Ericsson is doing.
All right. Thank you.
Thank you, guys.
All right.